students. So now we will going to learn something about the classic theory behind current in a conductor. There are some aspects which makes the current to make in a conductor. So that basic theory we will study. Okay, say consider a conductor. This conductor or any conductor contains lots of free electrons. You might have studied the classification of conductor, insulator and semiconductor. So insulator will not have free electrons or very negligible amount of free electrons. Semiconductor will have some free electrons, not much. Conductor is the kind of material where there will be lots of free electrons. So this conductor at a room temperature with this many free electrons, what will be the condition of this free electrons? They will be moving inside the conductor a random motion. All the electrons will be in random motion, or we say Brownian motion. So it will be in zigzag motion, no particular direction, but it will be moving around. So say for example, if this is one electron, if this electron is moving in this direction, another electron will be moving in the opposite direction. If one electron is moving in this direction, definitely another electron will be moving in this direction, opposite direction. So we can say the net velocity is 0, or we can say the average velocity. That will be the correct term. Average velocity will be 0. Can we say average speed is equal to 0? Is it correct? No, never. This is wrong. Average speed is not equal to 0. But velocity, if we consider, net velocity will be 0. So this electrons will be in random motion, and the velocity of these electrons we call thermal velocity. Thermal velocity is very high. It's of the order of 10 raised to 5 meter per second around. So thermal velocity is very high, but the movement of electron is random. So this system will not give us any current, will never give us any current. For current to flow like this, when electrons are moving in random motion, it is not possible to have current in one direction. So a conductor at a room temperature with a lot of free electrons having random motion at a very high velocity, that is called thermal velocity of the order of 10 raised to 5 meter per second, will not give us any current. Okay, this is important point which we need to understand. Okay, so pause the video, note it down. Now, what will make a conductor to make current? That thing we'll see now. A conductor which will be having lot of free electrons. Generally this will be in random motion with what velocity? With the thermal velocity. Does not give us any current. Suppose if we are able to apply an external electric field, to this randomly moving electrons inside the conductor, what will happen? If we supply an external electric field, this external electric field will apply some force on these electrons. You have studied, if this is electric field direction, suppose if we keep a charge here, the force on this charge F is equal to QE. You have studied this in electrostatics. Suppose if this is a negative charge, then the direction of force will be F is equal to minus QE, that will be in the opposite direction. So what will happen here? All the electrons will be moving towards left side, that is the direction opposite to the electric field, and all the electrons will accumulate here, and all the positive charges will be accumulating here. So here what is happening here? Charge accumulation happens here. So because of this, there will be an internal electric field that is happening inside in this direction. So what happens? The net electric field will become 0. So it stays like that. Now suppose if we are able to supply, if we supply external electric field, what will happen? Charge accumulation will happen. There will be an electric field that happens in this direction, and net electric field will be 0 once if we apply external electric field. So for the movement of these charges continuously, what we need to do? We will have to continuously supply this electric field. So that is how we will be doing now. What we do? We will supply an electric field continuously by connecting a battery. So when this battery is supplied, electrons will be moving in this direction. Electrons will be moving in this direction. So current will be moving in that direction. We will be able to make a current flowing in this setup, in the conductor. Now what this battery is doing? This battery is supplying charges? No, battery is not supplying charges. Battery makes these charges to move around. Continuously this moves around the circuit. This is what battery is doing. Now actually these electrons will align like this. That does not happen. What happens actually? See, now it is like there was no force on the electrons. Electrons were moving randomly. When we applied electric field, what happens? Electric field happens continuously. When we applied electric field, force started acting on these electrons. Now electrons will have to do march like this. Is it like that? March fast like this, just like how army people are moving or police people are moving. Electrons will stand up in the line and move. It is better to assume like that so that we will understand easily. We can assume like that, okay, but it is just an assumption. What happens actually is, suppose if an electron, if it is moving like this, because of this battery we have connected, because of this electric field, it will drift like this. If one electron is moving like this, it will be drifting like this. One electron is moving like this, it is going to drift like this. So this drifting will give us electrons moving across the circuit. So the velocity with which the electrons are moving under the influence of electric field when we connect a battery is called drift velocity. This is called drift velocity. It is not the velocity of one electron. Drift velocity is the average velocity of electrons in the conductor when we apply a battery on the circuit. Under the influence of battery, there will be an electric field. Under the influence of electric field, there will be force on the electrons. Because of that force, electrons will start drifting. This velocity is called drift velocity. So the average velocity of electrons under the influence of electric field is called drift velocity. Okay. Now I said there will be force F is equal to QE. That is, there will be a force under the influence of electric field on these electrons. When there is force, there will be acceleration. When there is force, there will be acceleration. Then is it possible to have a constant velocity like drift velocity for the electrons, average velocity, or drift velocity is a variable velocity or what? Okay, we will see what happens when happens to drift velocity or electrons, how this force is influencing the movement of electrons. What you are thinking is correct. F is equal to QE will definitely provide acceleration to the movement of electrons. That is correct. Now how this happens is, if this is an electron, in this electron a force is acting, there will be acceleration. It will be just, it is about to move in this direction, but because of this force it is drifting like this. Now here these electrons will have lot of obstacles in the path. It collide on the way with so many electrons, with so many ions likewise, and a lot of collisions will happen in between, and then it reaches to the other side. It moves around the circuit with a lot of collisions. So it will collide with another particle. This particle can be ions. How ions will come here? I said already, these are all free electrons. Free electrons might have formed from an atom. Suppose if this is an atom, from here electron came out, so this will have a positive charge. So likewise there will be positive charged ions will be there on the path. Ions, or we can say kernel, that also can be said. So these electrons, while coming under the influence of force with the presence of acceleration, it will hit or it will collide, or at least it is going to slow down under the influence of this ion. Now what happens after collision? The electron will be moving again. So after collision its velocity will change. Velocity will become 0. Then again while coming, its velocity will increase under the influence of acceleration. Again it will collide with another atom. So an electron coming, this is an electron, imagine this is an electron, under the influence of force it is coming, colliding with another atom or kernel or ion, it will get slowed down, again it will move, it will collide with another atom, okay, just collision, then again it moves. So even though force is there, acceleration is there, these electrons undergoes lot of collisions and it is going to move. Because of these collisions, it is going to move with an average velocity called a drift velocity. So it is moving with the average velocity called a drift velocity, even though force is there, acceleration is there. That the reason is because of this collision. Okay. So what we have discussed is a conductor will have lot of free electrons. These free electrons will be in random motion, and this will not have any particular direction. This will be moving in a zigzag manner, so the net movement can be considered as net movement. Actually we can say the net velocity can be considered as 0, because velocity has direction. If one electron is moving like this, another electron will be moving back. Because of this, net velocity can be 0. Net speed cannot be considered as 0. Now if we apply an electric field, if we apply a battery, there will be an electric field. Under the influence of electric field, electrons will drift and it will be moving in a particular direction. This is just an assumption. Actually drift will happen around 10 raised to 29 number of atoms are there in a small part of conductor. So many number of free electrons will be there. So what happens is this drift itself will create electric current. So under the influence of battery, under the influence of electric field, electrons will drift, which we call drift velocity, average velocity of electrons putting together, drift velocity. So there is a force because of electric field, F is equal to QE. Because of force there will be acceleration. So actually electrons should be having accelerated motion. But what happens, because of continuous collisions, the velocity of electron, the speed of electron will come down to 0. Again it moves further. So likewise it is going to move with the more or less average velocity, which we call drift velocity. Okay, now we will study the expression for drift velocity. So here there will be lot of electrons, free electrons. We connected a battery. So electrons will be drifting in this direction. Likewise, so current will be passing like this. So suppose if we consider an electron is moving in this direction, it will be colliding with the kernel or another electron or with some ions, positively charged ions, and it comes back. So here its velocity is u1, and again it is going to have another collision. So before collision it is going to have the velocity v1. So after collision again this v1 velocity will come down. So u1 v1. Here there will be acceleration, there will be force, so there will be acceleration. The time between two collision, is called relaxation time. The time between two collision is called relaxation time, which is denoted as tau. And this path, the path between the distance between two collision, is called free path. So the time between two collision is relaxation time, and the distance between two collision is called the mean free path. So it can just relax between two collision. It is just a thing like that, and keep it in mind. This is how. Another electron if we take, again this is going to collide. It is after colliding, it is going like this. So there will be collision here. So here U2, this is going to be V2. Again this also will have mean free path. This will have acceleration. This will have relaxation time. Now how to find average velocity, drift velocity, or generally we will take it, this is nothing but drift velocity itself. But how to find average velocity? Average velocity can be found by V1 plus V2 plus V3 up to Vn divided by n if there are n number of electrons. V1 plus V2 plus V3 plus up to Vn divided by n. Pause the video, note it down. We'll continue. So drift velocity is nothing but average velocity of all the electrons putting together. So how to find V1? V1 here, under the influence of force and acceleration, U1 becomes V1. So if there is an acceleration, there is a constant force, there will be constant acceleration. Under that case, how do we find velocity? We have studied that in motion in one dimension in first year topic. So V is equal to U plus AT, I can write. So here V1 is equal to U1 plus A into the relaxation time. Same way V2 I can write U2 plus A tau 2 if I write this is tau 1. Likewise I can write Vn is equal to U1 plus A tau n likewise. So substituting in this equation, I will have U1 plus U2 plus U3 Un V average is equal to U1 plus U2 up to Un plus AT, A into tau 1 plus tau 2 up to tau n. I can write like this, divide by n. So here after collision, for that moment electron velocity will become 0. So I can take this U1 plus U2 plus Un as 0. So V is equal to A into tau. I can write tau 1 plus tau 2 plus tau 3 divided by n. So this is tau 1 plus tau 2 plus tau n divided by n. So this is nothing but average. So A tau average divided by A into tau average. Now what is this A acceleration? If it is for electron, EE by m. Force F is equal to QE. So for electron I can say force F is equal to QE. For an electron I can say E into E. Then F is equal to MA. So A is equal to F by M. So this A I am writing as EE divided by M, mass of the electron. So substituting that here for V average, I can write EE divided by M into tau average. So this is what is drift velocity. So the formula for drift velocity is EE by m into tau average. Pause the video, note it down. This is the derivation given in Ncert book. Those who are preparing for Neet and JEE can understand how this is done, so that if any theoretical questions come, you will be able to answer it. Then those who are preparing for board exams for CBSE, Ncert follows the same derivation, so you can note it down. So students, we have studied about drift velocity. Drift velocity is nothing but the average velocity with which electrons move under the influence of electric field. So continuous electric field is possible by connecting a battery. We have seen that. Now we are going to study the relation between drift velocity and current. Okay. Consider a conductor. With the cross section area A with the length L. Okay, conductor. This conductor is connected to a battery. So when this battery has a voltage, constant voltage, this battery will give us a constant current. So when battery is connected, as we know, electrons will be moving to this direction towards positive terminal of the battery. Current will be moving from positive to negative. Right? Now, N is called number density. That is number density. Number density is the number of electrons per unit volume. N is the number of electrons per unit volume. Now, let us start with the current. I is equal to Q by T, charge by time. Why I wrote Q by T? Because we are going to have constant charge flow through this conductor. So Q by T. What is this Q? Number of electrons per unit volume is N. So N into E. So this Ne gives us the charge per unit volume. N is nothing but the charge per unit volume. Now, what is the volume of this conductor? Area of cross section is A, length of the conductor is L. So if I write A into L, I'll be getting the total charge in this conductor. N is nothing but the charge density, number of electrons per unit volume, into E means the charge in a unit volume, number of charge per unit volume. Now if I multiply with the volume, I will be getting the total charge present in the conductor. Again I am writing divide by T. Now with the what velocity electrons are moving? With the drift velocity. So I have written here N EAL by T. So this drift velocity VD is the average velocity, is nothing but L by T. Drift velocity VD, can I write L divided by T, time taken? This is the time taken for a charged particle to reach this length. So can I write VD is equal to L by T, velocity is equal to displacement by time. So I get VD is equal to L by T. Now I is equal to NEAL, substituting T is equal to L by VD, L by VD, L will be cancelled off. I will be getting I is equal to NEA VD. Current is equal to number density into charge of electron, or positive charge, one charge, or into A, area of cross section of the conductor, into drift velocity. So here we are getting a relation between current and drift velocity. So the formula of drift velocity, this is the formula of drift velocity, E force divided by m, mass of the electron, into tau, relaxation time, average relaxation time. Another formula is NEA Vd. So from this current also we can find drift velocity. At the same time, considering the length and time taken for the particle to reach the other end, we can even write this also, Vd is equal to L by T. So if the question data is only this much, we will have to use this formula to find the drift velocity. Now this is the theory of regarding drift velocity. Now we will do problems in the next session.